benzonitrile reacting aryl nitrate. Benzonitrile reacting aryl nitrate.
పాడైపోద్ది అట్లా వచ్చా తప్పదు
Trioxide. 1 comma 2 bipolar addition. Undergo 1 comma 3 dipolar addition reaction. Then it is addition takes place. 1 comma 3 dipolar addition reaction forms. One, 2, 4 oxidizole is the product. 1, 2, 4 oxidizole is the product. Okay. Next one, reactivity. When reactivity, oxidizoles are very big bases due to presence of minus inductive effect of extra nitrogen atoms. Electrophilic substitution reactions are unknown except halogenation and mercuration. So only halogenation and mercuration takes place. Only halogenation and mercuration takes place. Halogen in 5th position are more reactive than that of halogen in 3rd position in nucleophilic displacement. So in halogen in 5th position, halogen in 5th position is more reactive in the nucleophilic displacement reaction. This is chlorine and taken to dimethyl amine. So loss of HCl, this chlorine is replaced by amine group. This is the best halogen at 5th position is more reactive towards nucleophilic displacement than that of halogen at 3rd position. So next we are going to oxidizole. Second one is 1,2,5 oxadiazole. What is 1,2,5 oxadiazole? 1,2,5 oxadiazole. 1, 2, 3, 4, 5. 1,2,5 oxadiazole. This 1,2,5 oxadiazole. So when the synthesis of 1,2,5 oxadiazole is synthesis of 1,2,5 oxadiazole from 1 comma 2 bis oxames. From 1 comma 2 bis oxames. From 1 comma 2 bis oxames. One to bis oxames. This 1 to bis oxames in presence of heating undergo loss of water molecule. Undergo loss of water molecule. The product of 1,2,5 oxidazoles. The products of 1,2,5 oxidazoles. Reactivities. So base catalyzed displacement deprotonation occurs readily. This is mainly used to the cleavage. Okay, that means this 1,2,5. When this 1,2,5 oxidazoles, when reacting with sodium hydroxide, sodium hydroxide is a base, subtract the proton from 3rd position of 1,2,5 oxidazoles, then the negative charge is at 3rd position. Negative charge at 3rd position. This negative charge leads to cleave the ring. This negative charge leads to cleave the ring. Then O minus N. This is the opening of heterocyclic ring. That is 1,2,5 oxidazoles. Next one is 1, 2, 3 oxidazoles. 1, 3, 4 oxidazoles. 1, 3, 4 oxidazoles. So 1, 3, 4 oxidazoles. So 1, 2, 3, 4, 5. 1, 3, 4 oxidazoles. So synthesis of this 1, 3, 4 oxidazole is when reacting with benzaldehyde benzo benzhydrogens. When reacting with benzhydrogen, in presence of trimethoxy benzoyl, trimethoxybenzoyl, triethoxybenzoyl, then loss of here one intermediate will be formation takes place. Phenyl, C double bond O, N, H, NH, double bond in phenyl. So this is an intermediate. This intermediate undergo keto-enol tautomerism. This intermediate involves in keto-enol tautomerism. Then OH, phenyl. It is undergo loss of water molecule. It is undergo loss of water molecule. The product is 1,3,4 oxidazole is the product. Next one is next synthesis. Next one is oxidative cyclation of N-acyl hydrogens. Oxidative cyclation of acyl hydrogens. So acyl hydrogens, when these compounds undergo, when react with lead LDA, lead lithium disopropylamide, obstruct the proton. This is a base, obstruct the proton from benzylic carbon. Here negative charge, that negative charge is the causes to triple bond between carbon and nitrogen, and carbon with the positive charge, nitrogen, and here negative charge. Then R. So now it is undergo cycloaddition reaction. Now it is undergo cycloaddition reactions. Then forms then forms 1,3,4 oxidazole is the product. Next reactivity, nucleophilic displacement at good leaving group on ring carbon atom. Nucleophilic displacement of very good leaving carbon atom. And so next 1,3 oxidazoles on heating with the primary amines rearrangement to 1,4 triazoles. There is 1,3,4 oxidazole. This is important. Oxidazole when reacting with primary amine, then produces 1,2,4 triazole. 1,2,4 triazoles. So now the mechanism here methyl. When this compound reacting with the primary amines, pair of electron nitrogen, attack it here, second position carbon, and this involves opening the ring. This leads to involve opening the ring. Here double bond O and NH, here N double bond methyl NH with R. Now it is involves in the, so now it is here, this is involved keto-enol tautomerism. Then OH, N double bond, NHR. So it is involves loss of water molecule, then produce produces, so 1,2,4 triazoles is the major. Okay, next one, signones. 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 Next one is this of signones. When N-acylglycine N-phenylglycine, this N-phenylglycine reacting with the HNO2, N-phenylglycine reacting with HNO2, nitrosylation takes place on a nitrogen atom of glycine NH. Nitroso derivative will be formation takes place. This nitroso derivative, okay, here in this nitrogen contain lone pair of electron donated to nitrogen single bond, and this double bond between nitrogen oxygen transferred to oxygen side, and this negative charge is attacked at carbonyl acid carbonyl, and acid carbonyl. The product is O minus O N-phenyl positive charge, then N. So this is the signone. Signone nothing but 1, 2, 3 oxadiazole. 1, 2, 3 oxadiazole. This is important. 1, 2, 3 oxadiazole. Signone nothing but 1, 2, 3 oxadiazole is the signone. This is signones. This type of compounds are discovered in Sydney University in Australia. Therefore, the name as given by signones. Next, thiodiazoles. Next one is thiodiazoles. Thiodiazoles. These thiodiazoles are here 4 types. 1, 2, 3 thiodiazoles, 1, 2, 4 thiodiazoles, 1, 2, 5 thiodiazoles, 1, 3, 4 thiodiazoles. First, we are discussing with 1, 2, 3 thiodiazoles. 1, 2, 3 thiodiazoles. For synthesis of this 1, 2, 3 thiodiazoles, chloral hydrate is taken. Chloral hydrate is we are taking as a chloral hydrate. That is CCl3 CHOH taken to chloral hydrate. CCl3 CHOH taken to this chloral hydrate. This chloral hydrate react with tosyl hydrogen. This chloral hydrate reacting tosyl hydrogen, then it is involves in loss of 2 moles of water molecule. It is involves loss of 2 moles of water molecule. Then the product is Cl3C CH double bond N NHTS. This is the compound. When it is reacting with Na2S and sulfur, sodium sulfide and sulfur, then product is 1, 2, 3 thiodiazole is the product. This is a product. Next, reactions. Reactions. Thiodiazoles are very weak bases. Electrophilic substitutions are partially unknown, and halogenation and micronization are possible. Nucleophilic displacement of anionic groups from ring carbon occurs readily, amino group on ring carbon can be diazonated normally. Here I am taken when this 1, 2, 3 thiazole, 1, 2, 3 thiazole derivative when reacting with methyl lithium. So base abstract the proton from here. Base abstract the proton from here. Negative charge here, positive charge lithium, and it is involves reacting with carbonyl compound. Reacting with carbonyl compound, then negative charge attack at carbonyl carbon. The product is the second substituted product is a major. Okay. when if it is four substituted 1, 2, 3 thiazoles reacting with the base, ring opening takes place. When 4 substituted 1, 2, 3 thiazoles when reacting with the base, they causes to open the ring. This is involves like this. Here double bond N, double bond C, aryl S minus plus water molecule plus Na2 gas is liberated. When both 4, 5 disubstituted, 4, 5 disubstituted, 4, 5 disubstituted 1, 2, 3 thiazoles upon heating, they involves cleavage of the ring, elimination of nitrogen gas, plus here this carbon is radical carbene. This carbon became carbene, and here S sulfur. When it is involved in rearrangement, this is the product. Thioketone is the product. Next one is 1, 2, 4 thiazoles. 1, 2, 4 thiazole. 1, 2, 4 thiazoles. 1, 2, 4 thiazoles. When this 1, 2, 4 thiazoles next involves in synthesis of 1, 2, 3, 1, 2, 4 thiazoles. This is 1, 2, 4 thiazoles. 1, 2, 3, 4, 5. 1, 2, 4 thiazoles. When this 1, 2, 4 thiazoles, the reactivity is with thioamide. 2 moles of thioamide. 2 moles of thioamide. Reaction with 2 moles of thioamide. Then the product is so 1, 2, 4 thiazole is the product. Here mechanisms here when it is involved in tautomerism, SH phenyl. Again, it is also involved in tautomerism. So it is involves loss of H2, and it is involves loss of H2S. Loss of H2S. The product is N double bond phenyl sulfur carbon phenyl Pure nitrogen. This is the mechanism involves. Next one is when chloro perchloromethylene mercaptan. Perchloromethylene mercaptan. This is perchloromethylene mercaptan. This is perchloromethylene mercaptan. Perchloromethylene mercaptan. This perchloromethylene mercaptan reacting with amidines. Amidines, hydrogen chloride. Amidines, hydrogen chloride in aqueous sodium hydroxide. The product is 1,2,4-thiazole is the product. Okay. Next reactions.
सर प्रीवियस पेज का फोटो प्लीज.
What?
प्रीवियस पेज जो आप नोट कर रहे हैं.
I'm not understood your voice. Tell me once again.
The previous page जो आप
Okay, previous page. Okay.
previous page का please. Okay sir, thank you.
No, you don't. No, I will provide a notes after completing of this unit. I will provide a notes. Okay.
The derivation this page, I have noted this, but before I am writing, नेक्स्ट पेज को चल रहे हैं तो इसलिए ठीक है सर.
Next reaction. Halogen in 5th positions are more reactive than that of halogen in 3rd position. Halogen in more 5th position in halogen at C5 position more reactive than that of halogen at 3rd position. Here halogen, here any substitution I am taking. When this compound reacting with piperidine in ethanol solvent, loss of HCl, then the product is this is the product we are after. Okay. Next compound is 1,2,5-thiazole. 1,2,5-thiazole. Okay. This 1,2,5-thiazole reaction with synthesis of 1,2,5-thiazole. This is a 1,2,5-thiazole. When this ethylene diamine, when reacting with S2Cl2, then the product is 1,2,5-thiazoles. 1,2,5-thiazole is the product. Okay. Next one is Next one is react 1,2 diketones. 1,2 diketones. 1,2 diketones reacting with 1,2 diketones reacting sulfamide. 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 When reacting with sulfamide. So in presence of S2Cl2, in presence of S2Cl2, ethanol is a solvent, HCl is a reagent, then forms our 1,2,5 thiazole is the product. Thiazole derivative is the product. Okay. Next reactions. Halogen on ring of carbon can be replaced by nucleophile. Okay. Next halogenate C3 position or C4 position. Halogenate C4 or C3 position replaced by nucleophile. Just here I am taking an example. Here halogen when reacting with the base. This base replaces the nucleophile. Chlorine nucleophile. This is a compound. Okay. So next one is 1,3,4. 1,3,4 thiazoles. Thiazoles. 1,3,4 thiazoles. This, that is structure is 1, 2, 3, 4, 5. 1, 3, 4 thiazole. When this 1, 3, 4 thiazoles, when reacting with NN diacyl hydrogen, NN diacyl hydrogen, NN diacyl hydrogen, NN diacyl hydrogen, it is in presence of P2S5. In presence of P2S5, they undergo produce 1,3,4 thiazole is the product. Next one, 1,3,4 thiazoles are obtained from 1,3,4 oxidiols. When that means 1,3,4 oxidizole. This is 1,3,4 oxidizole. So 1,3,4 oxidizole. When it is reacting with P2S5, when reacting with P2S5, that oxygen is replaced by sulfur, then forms 1,3,4 thiazole is the product. Thiazole is the product. Next reactions. Halogen on ring carbon can readily replace by nucleophile. Halogen at second position or fifth position. Halogen at C2 or C5 readily undergo nucleophilic displacement. Halogen at C2 or C5 position readily undergo nucleophilic displacement. Loss of HX. This is a product. Okay. Next one is yes, when this compound, when if it is when this compound reacting with base subtract the proton, then negative charge develops an carbon atom, ring carbon atom. This negative charge involves in displacement. S minus. This is a product. Okay, this is a product will be formation takes place. Next, triazoles. Next one, triazoles. Triazoles. So 1, 2, 3 triazoles and 1, 2, 4 triazoles are major. Okay, 1, 2, 3 triazoles and 1, 2, 4 triazoles. First we discuss 1, 2, 3 triazoles. 1, 2, 3 triazoles. One, two, three triazole. It is existing in two tautomeric forms. Okay, hydrogenate first position, hydrogenate first carbon atom. Then it is existing in two tautomeric forms. This is 2H. This is 2H. Okay, 2H, 1, 2, 3 triazoles. Okay, 1, 2H, 1, 2, 3 triazoles. So this is a more stable than that of this one. Okay. Next one is synthesis. When triple bond, yes, click reaction, click reaction, click reaction. We're discussing click reaction. When triple bond reacting with, triple bond is reacting with hydrogen. When triple bond reacting with when triple bond reacting with azides, when triple bond reacting with azides, okay. So undergo 1,3 dipolar addition. Undergo 1,3 dipolar addition. 1,3 dipolar addition. Then the product is so this is the product. 1, 2, 3 triazoles are the major product. This is a very, very important click reaction. Recently, the scientists in 2022, the 3 scientists are awarded to Nobel Prize. They discovered this click reaction. Okay, in presence of copper acetate, in presence of copper sulfate pentahydrate and sodium ascorbate in DMF solvent. Next one is properties and substitutions. 1, 2, 3 triazoles resist N alkylation under neutral conditions. Under alkaline conditions, alkylation or acylation can take place at 1 or 2nd position. Two substituent the product is predominantly formed. Second substituent product is predominantly formation takes place. Okay, when this compound, already we know that 1, 2, 3 triazoles are existing in two tautomeric forms. One is 1H and 2H. 2H is more stable. Therefore, these triazoles reacting with N substitutions. When reacting with alkyl halide, loss of HX. So plus 1 alkyl, 2 alkyl. This is a major. This is a minor. Okay. So next, halogenation. Halogenation occur readily. Halogenation takes place readily when these triazoles reacting with bromine in 50 degrees. So bromination takes place at 4th and 5th positions. Bromination takes place at 4th and 5th positions. Nitration and it's a different metallation when if it is 5th position is free. If 5th position is free in triazoles, 1, 2, 3 triazoles, N-butyl lithium, THF solvent, proton at 5th position obstructed by the base. The negative charge. This negative charge involves in ring cleavage. Ring cleavage. Okay, like this. And when we going to, so 1, 2, 4 triazoles. 1, 2, 4 triazoles. 1, 2, 4 triazoles. These 1,2,4 triazoles are also existing in two tautomeric forms. 1,2,4 triazoles existing in two tautomeric forms. So 1H, 1,2,4 triazoles and 1, 2, 3, 4 triazoles. 1, 2, 3, 4. 4H, 1, 2, 4 triazoles. So these are the examples. So next synthesis of this 1,2,4 triazole is from N-diacyl diazo compounds. N-diacyl diazo compound in presence of P2O5. In presence of P2O5, so cyclation takes place. This is a 1,2,4 triazoles. Next one is aminoguanidine from second example synthesis. Aminoguanidine reacting with ester. Aminoguanidine reacting with ester in presence of pyridine. Upon heating, N double bond, NH2 R is the product. Simply, it is a formation takes place in substitution and reactions. In alkylation or in acylation. It is reacting with acid chloride by loss of HCl. CH3. So when it is reacting with methyl iodide, loss of HI. This is the product. So next, metallation. So this 1,2,4 triazoles, 1,2,4 triazoles reacting with N-beta lithium, strong base. N-beta lithiums are strong base. So base subtract the proton from here. So metallation takes place at 5th position. Here negative charge, lithium positive charge. Now it is involves reacting with any alkyl halide electrophile. This negative charge displays that electrophile. Next one is tetrajoles. Tetrajoles. So tetrajole means 5-membered ring with 4 nitrogen atoms. 5-membered ring with 4 nitrogen atoms is tetrajole. This is 1H tetrajole. It is existing in 2 tautomeric forms. 2H tetrajole. 1H tetrajole, 2H tetrajole. So when we 1H tetrajole. When isocyanates reacting with azides, azides, and let's go undergo 1,3 dipolarization reaction. So this nitriles, when reacting with the azides, undergo 1,3 dipolarization reaction. The products are tetrazoles are the products. Tetrazoles are the products. Next. So imidochlorides react with azides under transfer conditions forms one substituent. When reacting with azides, benzoic acid, then loss of HCl. This chlorine replaced by hydrogen, then forms N-phenyl N3. When it is undergo cyclization, then forms 1, 2, 3, 4 tetrazoles. 1, 2, 3, 4 tetrazoles are the products. Next, reactions. In substitution. In substitution, in these compounds reacting with, okay, hydrogen is replaced by alkyl halide. So when it is reacting with acid chloride, so these are the N substitution products. Next, when reacting with the tetrazoles ring systems resist electrophilic substitutions. Bromine managed reaction when methylation takes place at C5 position. Okay, when here only one carbon atom is there in tetrazole, that carbon atom at C5 position. At C5 position, one carbon is there. Now this carbon undergo different type of electrophilic substitution reactions. Iodination. When reacting the managed reaction, secondary amide for HCl, formaldehyde. So managed reaction. Aminomethylation. This is example. And halogen at 5th position readily displaced by nucleophile. Halogen at 5th position readily displaced by nucleophile. Okay. Halogen at 5th position readily replaced by nucleophile. Loss of HCl. That chlorine is replaced by different nucleophiles. And metallation. Metallation takes place at 5th position. Metallation takes place at 5th position. It causes ring opening. Causes ring opening. Causes ring opening. Yes. Okay. Like pyrolytical reactions. Pyrolytical reactions. Pyrolysis or pyrolytical reactions. This 1, 3, 4. 1, 2, 3, 4 tetrazole. first involves in ring cleavage. First involves in ring cleavage by loss of N2 gas. By ring cleavage, by loss of N2 gas, the product is phenyl, N positive charge, here N negative charge, and here phenyl. Now this compound undergo reacting with the triple bond. Now this compound undergo triple bond. That is 1,3 dipolar addition reaction. The product is in pyrrolidine is the product. Okay. So pyrrolidine is the product. Next, dimorph rearrangement. Very, very important. Dimorph rearrangement. Next, dimorph rearrangement reaction. When 1-phenyl 5-amino tetrazole, 1-phenyl 5-amino tetrazole, 1-phenyl 5-amino tetrazole, 1-phenyl 5-amino tetrazole, upon heating, they involves in ring opening. They involves in ring opening. The product is N-phenyl NH2 negative charge, here positive charge, triple bond N. When it is, I am writing like this for our conveniency. I am writing like this, minus N-phenyl NH2 N positive sir, triple bond N. Now it is involves in addition reaction. So the product is NH phenyl. So here, this is the major thing, negative charge. This negative charge is shifting here, then forms SH phenyl, NH phenyl, and N double bond N here, hydrogen. This is the product. Okay. This is a dimorph rearrangement. Okay. Thank you. Thank you.